Hi Year 12. Today we're going to be having a look at the reverse chain rule, which will fit in with Chapter 4, Exercise I in your textbook. Now before we do this, we need to have a think about, I guess, what we're doing when we're differentiating and when we're integrating. So what I like to think of is that differentiation and integration are the opposite of each other, and that can help us to put together some rules and some ideas when we're integrating some difficult functions. Okay, we're going to start off with just an example, a nice simple one that'll give us an idea of what I mean by that. Okay, so first of all, we're going to differentiate the function x cubed plus 2 to the power of 4. It says with full setting out of the chain rule. I'm not going to use substitution here. I'm just going to use the chain rule that we normally would use if you were sitting a test or just doing a question. So let's have a look at this. Have a look at A down here. Now what I've written is I've written d dx of x to the 3 plus 2 or to the power of 4. This is our y. So basically I'm writing dy dx, and that's just another way of writing it. So if you haven't seen that, d dx just means we want to differentiate this y here. And that's another way we can write our dy dx. So let's differentiate this using our chain rule. 4 comes down the front. So that 4 comes down the front here. We take 1 off our power, which is what we would normally do. We just need to remember that we're also going to multiply by the differentiated part inside our brackets. So let's differentiate that, and we end up with 3x squared. So you need to remember that, and that's the part a lot of people do forget. Don't leave it like that. You need to neaten it up. The 4 and the 3 become 12. Our x squared goes in there, and our brackets of our power of 3 go in there as well. So that's our answer. So let's think what that means. I've differentiated this function to get this answer. So I've gone that way. But what I can also do is now integrate this function, and I'm going to go the other way and get my original question that I had. So that's what we're going to use when we're using the reverse chain rule. We're basically going to be looking at going forwards and backwards and seeing if that can help us out. And that's what our next part's going to do. Part B says, hence, find the primitive of 12x squared times x cubed plus 3 all to the power of 3. Okay, so remember what hence means. Hence means we're using our information from previous parts of the question. So we're going to use our information from part A to work out the primitive of this. Now remember primitive? Primitive means we're going to integrate. We're finding the integral, and that's our symbol there. So what we're going to do is we're going to find the integral of our function. And if you have a look at what I talked about in the first part, the integral of that function is the reverse of what we got before. So that's our question that we had. So going backwards, we differentiated this to get this function here. If I integrate this, I get that. And that's what we're doing here. So if I'm integrating 12x squared times x cubed plus 2 to the power of 3, I get this as my answer, plus a constant. Now have a look at part C. Part C is saying hence again. So hence, we're going to use the information from before now to find the primitive of x squared times x cubed plus 2 to the power of 3. So we want to find this part here. We want to find the integral of that. Now, what we want to look at when we're doing that is the question above. The only difference between these two integrals here is the 12. So this one here is 12 times bigger than what we have down here. That means our answer is also going to be 12 times bigger than what we have down here. So what we're doing is dividing this by 12 to get this integral. So if I divide my answer by 12, I'll get my new answer as well. And that's what I've done. But what I'm going to do is I'm going to make a little change to my sheet here. And I'm going to write, instead of plus C, I'm going to write plus D, because I'd really be dividing that constant by 12 as well. So I'm going to pop down a new constant. So my new solution is 1/12 of the answer that I had before. And that's basically how our reverse chain rule is going to be looked at. Okay, let's have a look at a little bit more difficult question. Okay, the next question below says to use the reverse chain rule to find the integral of x times the square root of 1 minus x squared dx. Now I'm going to show you two ways to do this. What I suggest is if you're in my Extension 1 class, I want you to know how to do both ways. If you're just in the Year 12 Advanced, I don't think you need to know substitution. It'd be great if you did, but for this question, I think we won't. But I'm going to do the second, or the method that was similar to the question above first in order to do that, and we'll do a couple of them. So let's move over. I've done that over here. So I've just written out our question again. So here's our question on the left here, and I've just written that again with a power of a half. So this is what we're basically trying to find. Now, what I need you to understand when you're looking at questions like this, it's not always going to tell you that you need to use the reverse chain rule, but you need to look at that and understand that x is happening in two different parts, okay? There's a function out the front, there's a function behind it. So you can't just go and integrate by adding to the index, dividing by the index in this form. We need to come up with another method. You could, if you felt comfortable, get that x back under the square root sign. That's a little bit trickier and there's a lot of room for error in there. But I have shown you how to do that, where if the x goes, probably better to have a look over here, when the x goes back under the square root sign, we're squaring it. So we'd have an x squared minus x to the power of 4 or to the half. You could do that and work your way through. That's another way. But in this case, we're wanting to use the reverse chain rule. Okay, so in order to do this and look at the reverse chain rule, we need to have a think about what we did up above. We're looking at integration and differentiation being the opposite. So I want to have a look at this part here with the power of a half. And I want to have a look at where that would come from. What would I differentiate to get that? So I know that when I differentiate, I add 1 to the index and divide by the index. So this part here would come from derivative of this. So if I add 1 to the index, a half to the adding 1, I'd get 3 over 2. Divide by that 3 over 2, I'd be timesing by 2/3. So what I want to actually have a look at is I want to have a look at that to help me get my answer. And let's do that. So what I want to do is I actually want to differentiate 1 minus x squared to the 3 on 2 and see what we get. So let's do that. So remembering our rules and not getting them confused with our old rules, we're going to times by our index, so we get 3 over 2. We are going to take 1 off our index when we differentiate, so 3 over 2 minus 1 is 1/2. And I'm also going to multiply by the derivative inside my brackets. So I'm going to multiply by the derivative, which is minus 2x. I'm going to neaten that up, and what I'll end up with is the 2's will cross out. I'm going to bring the minus x to the front, and I'm going to get minus x times 1 minus x squared to the power of a half. So I'm going to have pop my 3 back in, I forgot my 3, minus 3x, 1 minus x squared to the power of a half. Okay, so let's have a think of what that actually means. So when I've differentiated this function, I get this one. So that means if I integrate this one, I get that one. Let's write that down. So if I integrate my answer there, so minus 3x times 1 minus x squared to the half with respect to x, I end up with 1 minus x squared to the power of 3x. So instead of going from differentiation to the answer, I've gone from integrating my answer back to what I got over there. So what does that also mean for us? So have a look at this part here. Okay, that looks very similar to our original question. I might highlight that. So this is what I've found, and this is what I want. Have a think about how that might link up. So the integral of this gives me this. Okay, and the only difference between these two is the minus 3. So what I want is minus 3 times less than what I actually have. So I need to do this to my answer, and let's do that now. So what I want to find is x times 1 minus x squared to the half. What I have is minus 3 times bigger, so I need to divide by minus 3 and apply that to the answer that I had before. And I probably should go plus c. And that's going to be my solution. When I integrate this, I get minus 1/3, 1 minus x squared to the 3 on 2 plus c. I probably should have a plus c up there as well. And that's my solution. So we're looking at, you might want to go back and play around with it. Okay, so we're looking at where we want to be, what I need to differentiate in order to get to that, and then working around in that way. Now, we're going to look at another method as well. I'm going to scroll over here, and what I might do is I might actually erase all this and go from scratch. Okay, so the other method that I want you to have a look at, and this is primarily for those in my Extension 1 class, But I would like everyone else to have a look at it, but I want my extension 1 guys to be able to do this. And what we're going to do is we're going to use a reverse chain rule, but we're going to use, I'm going to use substitution. This one takes a little bit less thought and a little bit more algebra. So what I can do is I can look at my function under the square root sign and use a substitution for that. So I'm going to let u be equal to 1 minus x squared. Now this u is the u that we might have used in our product rule, our quotient rule for differentiation. It just means we're substituting. So I'm going to substitute in u for my 1 minus x squared. I'm also going to therefore need to have a du dx. And my du dx would be minus 2x. So what I want to do is I want to substitute in for my x, for my 1 minus x squared, and try and get rid of all the x's so that I can differentiate, or sorry, integrate with respect to u. And there's this little dx here, and I'll show you what happens with that. So I'm going to now do a substitution. I need to substitute something in for my x. Now, if you have a look over here, I have a du dx is minus 2x, but there is an x there. There's an x here. How am I going to get x from that? Now, we want to start thinking of du dx or dy dx as something algebraic that we can manipulate. So if I was to divide by minus 2 on the right-hand side, I'd be left with x. So I can divide by minus 2 on the left-hand side. So I'm going to write minus a half du dx is equal to x. I've divided by minus 2 here, I've divided by minus 2 here, and that's what I've ended up with. So what I'm going to do is I'm going to substitute in for my x, and I'll highlight that there, that x and that x is going to have substituted in for it minus a half du dx. I'm going to write that in instead of my x. Minus a half du dx. And we're going to neaten this up a little bit, so don't stress about the order that it's in at the moment. My square root sign is going to have a square root of u, because that was our first substitution, and I still have a dx. Now, I am going to neaten that a little bit because I don't like that written like that. I like to have my dx at the end, so I want my du dx at the end. So I'm just going to write it as minus a half square root of u du dx dx. You don't have to do that, but that's what we're going to do. And what you see is there's a dx at the top, there's a dx at the bottom, and I can cancel those out. Now, this is something new that we haven't explicitly looked at and we'll look at more in year 12, but this dx is something that we're going to think of algebraically. Let's just think about that for now. So what I have now is I have an integral, the integral of minus a half. I'm going to write my u to the, with the square root sign as u to the half, du. I can now integrate this with respect to u because everything is in u. Let's put that back in there. Okay. So we can do that. So let's do that. What we're going to have is we're going to, our minus a half will stay there, and we're going to add 1 to the index. So we'll end up with u to the 3 on 2. Divide by that new index. When I'm dividing by 3 on 2, oops, I'm just accidentally deleting things here. Let's fix that back up. Okay, when I'm dividing by 3 on 2, I'm actually multiplying by 2 over 3 plus a c. I can cross these two out, and what I'm going to end up with is minus 1/3 u to the 3 on 2 plus c. Now we need to remember our substitution. So right at the end here, we can pop it back in terms of x. So our u was 1 minus x squared. So what I'm going to do is leave the minus 1/3 there, pop my 1 minus x squared back in there to the power of 3 over 2 plus c. And if you remember what our answer was before, they're identical. And I'm going to highlight those so that you can see that. So that answer there and that answer we got over there are identical. So they're two different methods that can be used to get the same solution. And I think it's really good to have that option for you to do those two methods, because you might find that you come across the HSC and you may need a solution, that a method that is an alternate, basically.